Hey, everybody, and welcome back to another episode of Adventures in Machine Learning. This week on our panel, we have Francois Bertrand.
Hello.
We also have Ben Wilson.
Hello, hello.
I'm Charles Max Wood from Top End Devs, and this week we're talking to Connor Murphy. Connor, do you want to introduce yourself real quick?
Sure, absolutely. And so first off, really happy to be here. It's a really nice opportunity to just zoom way out, talk about some of the first principles, some of the patterns in the field. But my name is Connor Murphy. I'm a lead data scientist over at Databricks. And so a lot of what I do is consulting engagements on either distributed machine learning with a focus on deep learning or ML ops. So a lot of nitty-gritty issues when you're actually trying to take machine learning models into production.
Right. Did you work your tail off to get that senior developer gig just to realize that senior dev doesn't actually mean dream job? I've been there too. My first senior developer job was at a place where all of our triumphs were the bosses and all the failures were ours. The second one was a great place to continue to learn and grow, only for it to go under due to poor management. And now I get job offers from great places to work all the time. Not only that, but the last job interview I actually sat in was a discussion about how much my podcast had helped the people interviewing me. If you're looking for a way to get into your dream job, then join our Dev Heroes Accelerator. Not only will we help you get the kind of exposure that makes you attractive to your dream employer, but you'll be able to ask them for top dollar as well. Check it out at devheroesaccelerator.com. So before the show, we were talking about kind of first principles for machine learning, but we were also talking about kind of the organizational soft skills also involved in that, because imagine this, it's a team sport, folks. So I'm not sure exactly where we want to start. Do we want to start with some of the technical first principles here of data science and ML, or do we want to dive more into the operational team interpersonal stuff?
I mean, it's totally up to the team. So I think it might be helpful just to kind of reiterate why we do this stuff to begin with. I find that it's
cool.
Yeah. Well, it's funny because as, a technical practitioner, you oftentimes, can lose, the forest for the trees. And so, and there's also a lot of talk of AI and data being overhyped. And I think that's patently false, right? The saying in software development is software is eating the world and AI is eating software. And one way that I like to frame it, and I think this is in part because I've taught a lot of very beginner programmers and beginner data scientists. And so it's really helpful to situate this in the wider context of what our overarching cognitive biases are, right? The normal ways that we make decisions has to do with how we historically do things, how we emotionally feel about them. And you can think of these cognitive biases kind of like the prison that you're in, because they really do shape the reality that you have. Or maybe they're the veil over your reality. Maybe saying the prison that you're in is a little bit too strong. But all that to say is that these statistical methods allow you to start to kind of push on those cognitive biases so that you can understand a little bit more about reality. And so I think in terms of first principles, first and foremost, statistical methods and data really do matter. And it doesn't really matter where we are in the hype cycle with this. It's really helpful to situate this as these are tools that we can use in order to make more and more complex and rigorous decision-making based on our ability to push against those cognitive biases.
Sounds like you're pitching one of our core company values, Connor. Let the data decide. Yes, it's an important aspect of analytics and data science /ML/AI in general is leveraging those foundational concepts. Some of these big companies that have been around for a very long time, they figured this out 100 years ago. They've been using data and statistics and proper analytics to guide their companies. And that's why they're the biggest companies on the planet.
Right, 100%.
And that feels like almost a great segue into that's the ideal world, right? Where the data decides everything. And then you have to deal with humans, unfortunately, where this is where you need to be cognizant of not only what your biases are, but what personal environment you're dealing with, right?
Well, I kind of, how do I put this? Like, I don't know that the data decides everything, because humans are the ones that decide what's valuable or what has meaning, right? But to a certain degree, yeah. I mean, you take the data and you can, like Connor's saying, you get to move past your own biases, right? By having a more objective measure of whatever it is, right? Because you just go gather information, right? You're not gathering information to prove you're right so much as just gathering information to figure out what's true. But once you know what's true, then you place the value on it, right? Or maybe you're trying to figure out what to place value on, and so you're gathering information to see what the real situation is. But at the end of the day, then it's okay, I'm going to take this action or not take this action based on whatever outcome I've decided I'm to place value on. And so it's both, right? And sometimes that's what we argue about, and sometimes we argue about things because we don't have all the data, or we don't have good data, or some of us have good data and some of us don't have good data, and so we're arguing about what the source of truth is. But I do find it very interesting that, this is a methodology for kind of clarifying what's real and what's not based on objective measures to a certain degree.
And you're absolutely right in saying we're the people who kind of provide meaning to these overall data sets. And going to kind of, the soft skills question that we initially mentioned, oftentimes a lot of these projects have problems with overarching leadership, which is what is the clarity of the vision that we're trying to solve here. Because once you have that clarity of vision and once you've truly infused the problem that you're working with some degree of business meaning, then all of a sudden you have all of these great statistical techniques in order to be able to optimize that thing. But it absolutely starts with what is the clarity of the problem that we have.
I think, you said the clarity of the problem we have, which is a little bit different from what I was talking about, because I was just talking about understanding the reality of the situation on the ground. But I think that's an important thing too, is being clear about, hey, what problem do we have? What will solve it? What do we think will solve it? And what information do we need in order to know whether or not that's a good approach or know what a good approach is? And that's kind of how we frame a lot of these problems.
Right, absolutely.
What were you going to say, Ben?
Oh, about a lot of times that you get called in to work with a customer, there's that fundamental gap in what Charles was saying and what you were saying before, of that vision of, hey, we want to use ML, we want to use our data scientists to solve some problem, but it's pretty non-focused. It's either myopic or, somebody heard about another company solving this problem and they saw some magical number thrown out there on some stage where they were talking about how the solution, hey, it increased sales by 40% for us because we used AI to do this thing. And some of the times, I mean, speaking from personal experience in a different aspect of the field at Databricks, I've gotten pulled into those projects before where somebody just has this very vague grand idea. And then that tagline, that summary is thrown to the data science team, and they spend months, if not years, trying to solve the problem. And eventually we get called. Like, hey, can you just help us solve this? Or can you solve this for us? So how do you navigate that process of bridging that soft skills gap that might be missing or broken at that company?
Absolutely. So I'll start by just kind of defining what the problem is and then walk through what's, effectively a change management strategy. But maybe I'll start in kind of a narrative way where maybe 4 or 5 years ago, I was teaching a night Python class for intro data scientists. So these were people who were interested in data science, had no stats background whatsoever, needed a Python class first before they start to, build out some of their knowledge of some of the other principles within data science. And you can oftentimes learn so much more from people who do things wrong rather than from the best in class solutions. Mm-hmm. And so I would be looking over the shoulder of these, individuals who were writing their first Python programs, and they would all make the same mistake where they would bang out 10 to 15 lines of code and then be like, I'm done. It's like, oh, well, did you run your code? And then they run the code and they find they have an error on line 1. And they just went to this high level of abstraction and complexity without fundamentally earning that complexity. And I think when you're writing code, the number of lines of code you should write is probably directly proportionate to how many years you've been writing code. So you should probably write one line of code at a time before testing it if you have 1 year of coding experience. And then once you have 2 years of coding experience, maybe you can write 2 lines of code. Maybe that's an exaggeration, but that's the way that I generally think about it.
I'd say that's pretty much spot on.
but the point is that complexity is always something that you earn. And I've seen this go on in so many different companies where they jump to the most complex solution that they can possibly fit in their head. They try and implement that thing, and then they have all sorts of downstream problems. And so the question that I always ask in order to try and unwind whether they earned the complexity of their solution or not is, how does this compare to some stupid baseline? And so did you train the simplest thing you could? Did you predict the average? Or did you train just a normal, ordinary least squares regression algorithm to try and solve this problem? And if you did that thing, and if you can say that my solution has a 20% improvement over baseline, or increases sales by 40%, or whatever the number we were talking about a moment ago, if you can concretely claim that, then you have earned that complexity. But so many times I've seen these individuals who are incredibly intelligent, and these are PhDs in whatever their respective field is. And they basically are making that same mistake that I was seeing with beginner Python students of, oh, I just found this very specific paper solving this very specific neural network problem. My use case is a little bit different, but I'm going to implement this specific paper that I see, and it kind of works. I can map some sort of input. I can log data into this model and get some sort of result back. But is this actually the optimal? Well, did you do the baseline, right?
Right.
And so that's something that I see time and time again. And a lot of what I work with various customers is really just asking those basic questions of, did we progressively move to this solution? Because when you progressively move to a solution, you generally speaking wind up having a solution that is much closer to what the total optimal solution is. And then in terms of the change management piece, so that's something that is so challenging to work with, because you're stepping into a political situation where individuals are already married to the solutions that they have. Oftentimes their sense of identity as being an effective data scientist is tied up with this idea that this solution is effective. And so a lot of what you're doing in those environments is really just change management. So there's my background before I got into technology. I spent about 4 years in nonprofits. And in nonprofits, there's an approach in developing countries called appreciative inquiry. And so basically, within, say, let's take rural Kenya, for example, oftentimes, if you're doing nonprofit development, some sort of humanitarian aid in those regions, your gut reaction is to go in with your preconceived notions as to, what this community should look like. And then you need some sort of outside resources in order to move that community in that direction. So appreciative inquiry is different. The idea is that you're first appreciating everything that's going on within that community. So understanding what their core assets are, and you map out those core assets, and then you figure out how to build upon them in order to institute some degree of change. And so when you're working with any sort of customer, it's very, very similar, where you have this map of different assets that are there. They all have the baseline skills. And many times you're working with customers who are smarter than you, but you just have to figure out how to, tune the knobs and levers a little bit in order to get them to that next level. And so starting out and figuring out what are their assets, what are they capable of, and then progressively moving in that direction is huge. And then another aspect of appreciative inquiry is when you're in those conversations, you're, celebrating their solution as much as possible, in part because, that's how you create connections with other people, but also in part because if you're undergoing a process of change, you need to be receptive of change. And so it's helpful to get people laughing. It's helpful to celebrate the progress that they've made so far, so that they know that you're not a threat. You're not, out there for their job. You're not trying to make them look bad, and that you can work together in order to find that next level of solution that they hired you to help build.
Definitely. That personal connection from consulting, I'd say that's important, but it's also important for any of our listeners who are a senior person coming into a junior team as a data scientist. A lot of companies, they sometimes when they struggle with data science, they've been doing it for a while, they can't really get their things into production. And they look at their staff. And they're like, oh, we hired a bunch of people straight out of school. There's nobody who's really experienced. They're experienced in building models, but not in the full journey of getting something into business realization of value. So they'll go and hire somebody with experience. They'll go look for Connor or me and be like, hey, we need a lead data scientist, or we need a director of data science who's a technical background person. So if you're one of those people who's coming into a more junior team, I think it's incredibly important to do the same thing, which is build those relationships of trust, but also do not attack what has been built before, even if you know it's garbage or it's convoluted or super complex. Something I've always found that's important is to communicate the value of maintainability in ML. Those simpler solutions, even though they're not as fancy, and that gets back to something you were saying earlier, Connor, which is about how somebody's identity as a data scientist is directly coupled to the complexity of their implementations. It's something that you do see. It's pretty common. Like, hey, if I'm not using TensorFlow, then I'm not doing AI, or I'm not solving problems properly. It's like, no, it's just a tool. Like, use the tool that's appropriate for the project. Like, it doesn't matter.
That baseline approach really reminds me of it's almost like the process equivalent of premature optimization is the root of all evil. But you're trying to go for the most complicated thing. You don't even, instead of just getting it to work and seeing, the baseline. That was, I thought it was interesting. Anyway, sorry, Ben, carry on.
Yeah, I'd really like to hear from Connor about that topic in particular, premature optimization. A lot of times you're brought into these clients that they have in their mind a production code base that they've worked on. And I'm sure you've seen it. I know I've seen it working with some teams where the code looks really elegant. It's structured correctly. There's no real code smells in it, but it's not something that you can just look at and in a number of hours totally grok everything that's in there. It's so complex and so convoluted that it's difficult to maintain. So how do you message that to a team that's built something that is prematurely optimized?
By the way, just to chime in here real quick, a friend of mine and I had a system we were going to build way back in the day, and it was a code review. And it was a unicorn code review. So it would review any code, any system, you just submit it, and it would churn for a minute or two, and then it would come back and say, your code sucks. just saying. I mean, but the point is everybody's code sucks, right? Everything has problems. So just coming in with this perspective, I think if you come into a team that has a healthy dose of humility, then what we're about to talk about, how do you approach this? It's a lot easier than a team that has a whole lot of ego tied up in stuff.
Exactly. Yeah, I think there are maybe two main ideas that relate really well to this. The first is that, similar to the truism that Francois was sharing, the biggest gain you ever get in performance is to go from not working to working. And that's it. Like after that, it's all just incremental improvements. And so oftentimes, a lot of the recommendations are take a huge step back and get something that's absolutely basic working. And then the other kind of truism that I think is really helpful is an idea that comes from philosophy. And so maybe in the 1900s, there was this idea floating around that maybe all of the really hairy, difficult questions of philosophy weren't actually that difficult. We were just using really complex language about it. In reality, if we had used clearer language, it would have been a lot, like we would have had answers to all of these questions. And so maybe that's overly simplistic, but I think that definitely applies to code, where it's easy to, get into a customer engagement. You have this giant code base. How do you actually sort through this thing? And you have so many lines and lines of code. And then you wind up, talking to the lead developer, asking them one or two questions. Have you tried these things? And then they say no. And then you're like, oh, maybe this is the path forward. And so the thing about code is, I've seen this time and time again, and I'm sure everybody on the call has seen this as well, whereas it's easier to write code than it is to read code. So everybody just wants to write their own code and push that code rather than trying to understand somebody else's code and then, make iterative improvements upon that. And so
just like Twitter, right? It's easier to tweet than to understand where other people are coming from.
Exactly. And so all of that to say is learning how to ask really good basic questions. I think oftentimes we don't ask the really basic questions. And maybe this is, going back to the ego thing. Maybe this is also, I feel like if I ask this basic question, people will think that I'm stupid. But it's oftentimes, those really basic questions that are the most illuminating. And they give you a lot of insight into whether the complexity of the system was earned or not. And it all goes back to the baseline issue. I know that's the most textbook response to what are the first principles of data science and ML ops, but it's absolutely critical. Maybe I'm just being the Mr. Miyagi from Karate, data science. But I do think that a lot of, the maturity that you find within data science and ML engineering comes down to the fact that you're just practicing the same basic skill set over and over and over again. You're not going and chasing, the latest, neural network papers, because the thing that you learn once you've read enough of those papers is that the latest neural network techniques are oftentimes incredibly brittle. Because the way that we publish these papers, there's an incentive to publish these papers. And sometimes they're great and transformative, and sometimes they're very specific to a given use case. And so I deal with customers all the time who get married to a specific paper they have. It was published once. It maybe has a couple of citations on top of that, if that. But they find this paper and they want to be able to adapt it to their specific use case.
And there's no code in that paper.
Exactly.
And no repository to show a demonstration.
Exactly. So then you make a really robust code base, and maybe it's easy to make mistakes when you're doing something like that. And it's easy to obfuscate, I accidentally tweaked my target this way, or whatever else that winds up having some sort of error where your model underperforms. And so all that to say is, if I'm the Mr. Miyagi of data science, it's that repetition of the same basic ideas over and over and over again that allows you to have a sense of, maturity and productivity in this space, more so than understanding the very specifics of the latest, neural network approach.
Yeah. I mean, but the team in the field at Databricks had a customer that we were working with that exemplifies exactly what you're talking about, where they had seen a new implementation of a tweak that you could make to an LSTM. And there was no code in the paper or anything, no examples, but it wasn't that hard to adapt the structure. So they built it, and it took them months of building that and had it all running. It took just every iteration, every training cycle that they would do because of the architecture of it. And it was sort of this ensemble approach that they had to do this, marrying LSTM and the convolutions. And this sort of a deep and wide LSTM. So as they were running through this training and evaluation, it just took forever, and it required a lot of hardware. And one might think, Databricks, you should be happy about a customer using a whole bunch of hardware. That's how you get paid. And that's not how we think, and it's not. You can confirm as well, Connor. It's not how we do business. So we were in there to try to help them, and we ended up asking that same question. We're like, "What is the use case you're doing?" Oh, you're just forecasting a time series. And it's a multivariate time series with some additional regressor elements that come into it. But it's did you try ARIMA or Ceramax, or did you do any of these other historical prior research implementations? And it cut to the heart for them. They were offended in a way when I asked this stuff at first. They're like, well, why would you bring that up? That's simplistic. That's never going to work. I'm like, well, can we try it? And we found that the metrics, the one that they were using, RMSE, across the time series horizon on back testing, it wasn't just that was the difference in performance and predictive power between these two on the exact same back testing holdout sets. It was the difference between them was less than 1 e to the negative 6 on pretty much every metric that we measured, except one was 150 lines of code. The other one was 1,000 lines of code. And the total cost of ownership was orders of magnitude less. So when you see stuff like that, how do you navigate that? When you're having that conversation where they have something that's built and they just want you to make it run faster.
Oof. I mean, like, I think it's, like willingness to put yourself out there and suggest the classical statistical algorithm. I mean, first, it's helpful to kind of empathize with where people are at with that, because I think people choose those design patterns either because they find it to be really interesting and they want to optimize for the most interesting thing rather than the best performing thing, or their sense of ego is involved in what they're doing, or they're optimizing for a line on a resume for how they get their next position. And so those seem to be the three main motivations that people are operating under. But as technical people, like we all love complexity, right? Like we all love like the nuances of, oh, how can I use an LSTM plus a convolution plus whatever other,
a graph embedding.
Yeah.
I want to say that to my mom. Do you know what I did this weekend?
Shoot.
That conversation is a corollary to how you're going to explain to the business how that thing works, by the way. That I'm going to explain to my mom.
That's a whole skill in and of itself, too. That sometimes when you're talking about, hey, they've got a team, they've got something in production, it's sort of working. Yeah. Explaining, okay, here's where we're going next, or even just we've never done anything like this before. And then you're just speaking Greek to them, you got to break it down.
Right. And also like understanding what consulting is. And so for us as technical consultants, we have a different role than say a management consultant. Whereas like if you're a management consultant, some of those consultant agencies are hired because a company wants to do a round of layoffs. And so they need to justify that thing. And it's easy for leadership to say, hey, this consulting firm recommended this thing. And so we're going to do this thing. And so part of the reason that this happens not very often at all in technical consulting, I find, but every so often it is the case that you're brought into a certain account in order to validate what they're doing overall, because they want that positive reinforcement to know that amongst the data science skills that they have on that team, they could zoom way out and they chose the best overall methods. And so there are many reasons why you would hire a consultant, and that being one of them. But at the end of the day, going back to this question of how do you deal with that level of, how do you deal with kind of unwinding the complexity of these projects? I think it just goes back to, am I willing to recommend the classic statistical approach, right? The random forest rather than, the much more complex solution? Am I willing to look kind of dumb there in order to see if this approach isn't going to beat their baseline? And so I think it's just like, I don't know, maybe I am really the Mr. Miyagi of data science. There's humility to it of saying, oh, I'm humble enough to know that, maybe a basic statistical technique is more rigorous than this other approach. Oftentimes, we're called in to deal with distributed machine learning use cases. And so if you're dealing with colossal data sets, statistically speaking, a more complex algorithm like a neural network is going to scale better as your data scales. And so you can do a distributed random forest across the colossal data set, and you will likely see improvements as you throw more data at that algorithm. But statistically speaking, a neural network is going to perform better. So all that to say is don't avoid neural networks, just earn the complexity.
Yeah. And a lot of times you look at a problem that they're trying to solve, and one of the things that I ask up front is, how critical is accuracy for you, or the performance of this algorithm? And I don't ask that to the data scientists, because they're either not going to have thought of that or not care, or their answer is just going to be as good as it can get. That's all we care about, because that's what they're optimizing for. I usually have that with the project manager or the actual business unit member who cares about this project most, and say, hey, what you have in production right now is 97.89% accurate in predicting what it's trying to do. And what you were doing before with humans doing this classification, how accurate were they? They're like, 55% accurate. I'm like, well, what's a win for you? And a lot of times they'll be like, 90%, that's fine. We're not expecting perfection here. And then you run that classical statistical method, or the old school ML, where it could be like a decision tree classifier or something. It's super simple to build, really fast, cheap, easy to maintain. And you find that it hits 94% accuracy. And sometimes that is the conversation that I've had to have, is bridging, with getting back to that soft skills, bridging that communication between the business unit, the subject matter experts, and the ML team to say, hey, this is all that they care about. This thing is 1,000 times easier to maintain. Don't throw away your deep learning code. Like, keep that in your back pocket in case the business says, hey, we need to actually drive accuracy up. But have that as a comparison to say, we can drive accuracy up if we spend this amount more money on retraining periodically, and we need to hire another headcount to maintain this more complex implementation.
Right.
Yeah, that's the fun conversation where you're brought in to validate an approach, and then the first thing you think is, "Oh my God, burn it with fire," and then you gotta take that.
Yeah, I've had those.
And then you got to take it to the team and like, okay, what you're doing is great, but
well, I think further to your point, Ben, a while back, everybody would talk about agile data science, and where a company is in their overall data maturity is a big indication of how much time they should spend optimizing those performance metrics. And so earlier on in a company's data maturity, generally speaking, it's more productive to have your developers skipping around, training some pretty basic models across a wide variety of use cases. And then that's the best way of optimizing the overall business. And then once you become more mature and say your entire business value, say you're Google, and the value of your business is completely tied to the performance of just a select few algorithms, then you want to spend so much of your time and resources on all of the fine tuning. But oftentimes you do need to really earn that. And at the end of the day, earlier on in your maturity, you really just want to have your team skipping around doing basic forecasting models. Everybody needs financial forecasting, basic models for whatever other areas of the business you have. And then you can start to finely tune as your use of data becomes more mature.
Yeah, that low-hanging fruit paradigm is something that I don't even know how many times I've gone through that speech with people. Mm-hmm. Sometimes we're brought in to deal with a company that we're interacting with their first data scientist that they've hired, who's been employed at that company for a grand total of 3 weeks by the time we start talking to them. And they're like, I don't know what project to work on first. They told me to solve this image classification problem because the app needs it. And sometimes we try to pivot that. Be like, hey, you got us for 6 weeks of full-time work. Do you want to solve 4 things? And then we can block out what that image classification is going to look like, so that you can get all these quick wins under your belt. And the only way to do that is exactly what you said. Keep it as simple as possible and make sure that you're providing value quickly.
Right. It's doing ROI calculations on all these projects, right? Like you said, a lot of low-hanging fruit, or why, I don't remember who asked the question, why are we even doing this? And yeah.
That is an important question, though.
Yeah, it's very Office Space. It's what would you say this algorithm does here?
I can confirm that in my life prior to working at Databricks at companies, I have been the creator of such projects. Usually not on company time, but just out of curiosity, I've got access to the data and I want to try to build this thing. And you have to be very careful not to push that onto the team, or, if you're exploring something out of curiosity, don't let the rest of the business know about that in case they think, oh, this is going to solve problems. Because it's no, this is crazy, or it doesn't do what we want it to do. What's scary is walking into a group of data scientists at a customer and seeing that almost everything that they have, the 3 or 4 things that they have in air quote production, are all that. It's hey, why are these running? What do they do? Who in the business cares that they're running? Or, who's consuming the predictions that these are outputting? And then you just get crickets in the room, people staring at each other with scared looks on their faces. And then you realize that nobody knows who's actually querying this data or using it. And nobody really knows why it's running.
And a lot of that comes down to, organizational politics and leadership. So one of my favorite stories of misaligned incentives and data comes from a buddy of mine who is a developer at Facebook. And so he basically, the way that their data engineering teams are incentivized is you build a Hive table in the case of Facebook. And how many times did other people in the organization query your table? So they're incentivized based upon that metric of building a table that is useful for the rest of the company. Then they're also incentivized on deprecating older tables as well. So what you wind up with is a really perverse incentive where first nobody documents what's actually in the table because you want to optimize for people querying your table. And so if you document it, they're going to query it less. So first you incentivize people to not query, to query the table as many times as possible. And then if you do happen to create a table that's not very popular, you're double incentivized to also deprecate the old work that you've done. And so all of that to say is there can be so many different leadership issues. And oftentimes, more often than not, it's just a lack of clarity. It's, oh, I read these articles. I should be doing AI. Let's hire people to do AI. And then we're going to find the use case afterwards. And so it kind of goes back to what you see within the entrepreneurship space. Like if you go through Y Combinator, the idea is, you start with a product and you push that product through to completion. You do not get a team together and say, we should start a company. What do we want to do? Right? And the same can be true of machine learning, where like you start with an ML product. I want to solve this thing. And then you push the thing through to completion rather than say, I'm going to amass a data science team and then we're going to figure out what to do afterwards. And then you need, the full maturity to not only, know the business value of that thing, but also to be able to push that thing into production, maintain it when it's in production, have the resources to actually maintain that thing. Because as we all know from software development, but for whatever reason, the data scientists haven't figured this out yet. But from software development, we know that the majority of the cost of software development is in the long-term maintenance of that software. Mm-hmm. Whereas, the same can be said of data science. It's just the way that we organize data science teams right now is not geared towards long-term maintenance of these models. It's mostly geared towards how can I build a proof of concept? How can I optimize that? How can I push into production? And then maybe some full stack developer who doesn't really know what like machine learning is will be responsible for the long-term maintenance of it. But that plan is always, not necessarily as fully fleshed out as it should. And so going back to this data maturity piece, one of the things that we oftentimes make as recommendations, we're generally not asked these questions, but we oftentimes make these recommendations to clients in addition to the other recommendations we're making, which is how can you organize this team in order to have an embedded ML engineer so that they can long-term maintain these things. And when we talk about ML engineers, still that's not a fully defined persona. Normally what we wind up with ML engineers is oftentimes they're a full stack web developer or a data engineer or an infrastructure engineer who's trying to do some stuff with machine learning algorithms as well. And so based upon the biases of your background, you'll wind up building different infrastructure that may or may not make sense. And so the trend that I've seen a lot recently is full stack web developers will be put in that role of productionalizing machine learning problems. And for a full stack web developer, they love everything as REST endpoints. And so they just build microservices architectures with a bunch of REST endpoints, which may or may not be the best decision overall. But all that to say is having a well-defined plan for the long-term maintenance of those models and being realistic with the cost of the maintenance of these models and making sure that they're constantly aligned with the business is, a huge, area of the field that right now we're just not very good at.
Hey folks, it's Charles Max Wood, and I just wanted to jump in here and let you know about something that I'm doing. It's free. It's out there just to help you get answers to your questions about the things that you're running into with your career. So if you have questions about how to get further ahead in your career, how to start a podcast, how to get a better job, how to get a raise, how to deal with a situation at work with your boss, or just maybe you're stuck and you don't know where to go next. How do I get from junior to senior to whatever's next? How do I become a speaker? How do I get to the next level? That's what I'm out here to do. So every Wednesday at 12 o'clock Mountain Time, I'm going to be doing a call, and it's going to be free, totally free, Go to devchat.tv/level up and you can register for the call. It's using Zoom's webinar software, so it's pretty straightforward. And what we're going to be doing is I'll do 10 minutes and I'll just show you how I do some form of how I level up. And then we'll just answer questions. And it's not going to be a question and answer like, hey, what's your favorite flavor of ice cream? And then I say Rocky Road or whatever, right? Instead, what we're looking for is more along the lines of, yeah, I have this situation. How do I handle it? I'm trying to figure this thing out. How do I figure it out? I'm trying to stay current. How do I stay current? And if you have any of those kinds of questions, I'll bring you on the call. We'll ask some deeper questions. We'll make sure we get you a solid answer. And I'm really looking forward to helping some people out. There will be no sales, no selling, no nothing on these calls. It is literally just 10 minutes of training and then Q&A. So you can go check it out at devchat.tv/level up.
Yeah, something that I've seen, to go off of that point that you're saying about who these people are that are embedded in teams, something I've seen work out very well is at companies is to do exactly as you said, focus on a project or a problem that the business has and define that, scope that out, figure out what are we trying to solve? What are the requirements? How are we going to measure it? How are we going to maintain it? But don't focus on the tech aspect of that at that time. Like think about it holistically as the project, as an entity. Like we're shipping a product, just like you would ship a new version of an app that you're doing if your company's building that. It's the same thing. And you get that concept down first, and then you move into staffing and technical requirements and architecture. But what I've seen companies that can be very agile and rapidly iterate on different things that they're testing to get that product built are the ones that dynamically create teams based on the project at hand. They'll say, oh, well, we have something that's going to be interfacing with our web app or with iOS app or something. We need 3 front-end developers, full-stack developers to come in on this team to help design that REST API and all the infrastructure there. We need a back-end software developer who's going to be understanding how to pipe the data into this model as most efficiently as possible and handle, asynchronous operations and make sure that we don't have a race condition going on in the, feeding to the REST API. And then you need the data scientists and some ML engineers or people that understand ML ops infrastructure to all work on this project together. Those cross-functional teams where you're getting all of those people together, as well as including the business in them, are the ones where I see the most success.
100%. Yeah, you need that diversity of background, that diversity of opinions. And as a data scientist, you want to optimize for hiring the data scientist that's smarter than you are so that you can learn from them. But in reality, hiring the diversity of opinions is, so much more valuable. But when I first started at Databricks, I worked very closely with somebody who I think is, one of the most talented developers I've ever met. And he liked to remind me that he was writing Linux code since before I was born. And so you probably know this person, Ben, but I learned a lot from working with him. And for him, he was, very much, a Java Scala developer who was always talking about these random new design patterns within Scala that, I didn't really understand, but it was really fascinating to listen to him. But it's through that diversity of opinions that people push your knowledge in different ways. And in my past life, I was on the faculty of a data science master's program, and I was focusing on data engineering. And it was fascinating because we had basically 2 data engineering courses. We had a standard data engineering course, then students would go to an internship, and then we'd have an advanced data engineering course. And the students hated that first data engineering course because they're like, why do I need these different tools? Why do I need to distribute my, workloads? I can already do all this stuff in pandas and blah, 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 blah. Then they would go to their internship, and then they would be grappling with a real world data science problem. And then they would come back to advanced data engineering. And when they would come back to that second course, they'd be like, oh, I get it now. Now I'm actually going to pay attention in your course because I see how valuable these skills are. And so when I would mentor junior data science folks, one of the most consistent messages I would always give them is, learn the software engineering best practices, learn the data engineering best practices. You're going to hate it. You're going to hate learning Spark because you already know how to do this thing in pandas. You're going to hate this syntax, but this is going to allow you to scale your impact over time because, as we all know, the more data that we can throw in these models, the better they overall perform. And it's that well-rounded skill set that really allows you to, advance in your career and advance in the level of impact you have in various organizations.
That was like a mic drop. Yeah.
My mic's, secured to the table. Otherwise, I would drop it.
Damage to my diaphragm.
That's pretty sage advice. And it's something that I think a lot of particularly junior data scientists struggle with when they get into their first role as a data scientist. They have no prior work experience or very limited. They've been doing something for like maybe they've been an analyst for 3 or 4 years, or maybe they worked in data engineering for 3 or 4 years. They're still relatively junior in their career, and then they come in as a data scientist, and they're like, wait a minute, I have to do all these other things, and I have to think about architecture at scale, and like, wow, the data is super messy, and I know how to do this, and the tools that I learned during my data science boot camp, or courses that I took in college or in post grad. But the real world is a different story, and the more of these tools that you understand and are familiar with, and realize that even though it sucks when you first start doing it, eventually you'll just start absorbing more and more of that knowledge and wanting to have more tools in your tool belt to tackle these things.
Right.
Because data in real companies in the real world I've never met a pristine data set, regardless of the company I've worked with.
Exactly. And that's a fundamental problem with how we teach data science. And I think that there are tons of assumptions that get baked into you when you learn data science. But two of the main ones are, first and foremost, we teach data science like it's a Kaggle competition. So here's this, structured data set for you, optimize for this, optimize for your error against this target variable. We chose the target variable for you. And so that's fundamentally just not how data science works in the real world. I think the second major issue is that so much of the literature that's published on machine learning is all based upon static data sets. Whereas in the real world, our probability distributions are constantly changing. And so many people get on their first job, and first they have to figure out how to translate a business problem into a data problem. So they have to learn that soft skill. And then they have to learn how to deal with time-bound data, even if there's not an explicit time component to the data set that they have. And so it's a lot of unlearning of the basic principles that you have within data science. And so much of our education needs to be revamped for that. And then if you're interested in a new field, if you are interested in publishing in data science, one of the coolest things you can do right now is drift monitoring, because drift monitoring is largely trying to account for the fact that, we generally speaking don't teach time-bound data well. Yes, we have, Facebook's profit library and, ARIMA and all of these different methods. However, there's a subtlety to the way that real world data sets integrate a time-bound component. And there needs to be kind of a large increase in the amount of research that goes into these methods. And drift monitoring is one of the main focuses of, how can we better incorporate time-bound methods into the way that we're understanding data science methods.
Yeah, we mentioned on a previous episode how it might be cool to have Kaggle run model maintenance competitions, or to kind of really put a big focus on that in the community. How that could be an interesting thing. Although I don't know how they'd integrate that into their existing system, but it would be kind of nice to see it addressed more generally in the field.
Yeah, I love that. Yeah, the other thing one thing that Kaggle has done so well is I forget their technical term for it, but they started to limit the compute power that you can use in the training of your models as well. And so, I don't know, 4 or 5 years ago, I had friends who would heat their apartments in the Bay Area with the multiple GPU racks they would leave running all night. It's doing these Kaggle competitions. And it's that's cool. You're talented at what you do. You also just threw a ton of money at this. And so I do like that trend in Kaggle to say, here are the compute resources you can use. They're limited. Go ahead and use these compute resources. So all that to say is, not to talk badly about Kaggle. I think they've done incredible things for the field. But to your point, Francois, yes, absolutely. Some of those approaches could evolve.
It's also interesting. I mean, we're having a future guest in a couple of weeks who is trying to solve that and is working towards solving that drift monitoring in open source software. But a lot of these techniques, any of my fellow ex-industrial engineering factory workers out there will kind of chuckle at this, but this problem there's an entire field study that's around it. And I think the ML community and data scientists are just now warming up to something that has been around for a very long time. There's just statistical process control. It's how factories run. The entire field of industrial engineering as a field of study and application in industry, it's what they do. It's old school quality assurance. It's saying, I have a process that I'm looking at, which is in our parlance, is a feature within a vector over time. How much is that changing? What is the acceptable variance over that? The study of that is the foundation for something that people sometimes see in taglines of people's names on LinkedIn. 6 Sigma green belt, 6 Sigma black belt. That is what that is. It's 6 Sigma is the study of process, like statistical process control, and how to control a business process or an industrial process to make sure that you're consistently producing the same product in the most efficient way. And we're doing the same thing in ML. Our model is our product, but it is a living thing. It's just like a factory floor. The raw materials that are coming into our factory are changing over time. The dimensions are changing. The composition of it is changing. The way that the outside world influences those materials changes as well. And thinking of any ML product that gets produced as that sort of factory floor of variation coming in, how is that going to impact my widget that's coming out? My widget is my prediction, and monitoring that and making sure we have eyes on that, and we have statistical processes on that to say, here's when to set the alarms off and say, hey, we need to retool our factory, which is retraining our model.
I love that. Yeah, I think you should start a consulting firm called 6 Sigma Data Science and, apply all those same practices.
Oh, I'm sure it already exists, man. But I think that's the next iteration in our field, which is people getting serious about this, because production ML at large companies, like you were mentioning, Google and Facebook, they have this figured out. Like they know how to do this. They base their company on these things. So people take that very seriously. This is more of a message to small startups that maybe don't have experience, or companies that have been around for a while, but they're just now sort of getting into data science. These are the things that are going to become very important for them to make sustainable ML over the next couple decades.
Right.
Oh, you were making me feel so industrial. I mean, just completely blue collar, No, it's interesting too, You could even make your belts so that they're like logarithmic instead of linear or something. Anyway,
That's
it makes
interesting.
sense though, right? Just the standpoint that you're talking about here. I mean, they've built their entire companies around this, and anyway.
Right. And it's interesting because so many of the skills that we need within ML ops are kind of already there within software development, but there are distinct differences, right? So one of the big tasks that comes up in virtually every customer account that I'm in now, and this wasn't the case, a year ago or 2 years ago, is CI/CD specific for machine learning. And so CI/CD is something we've been doing for eons, right?
Yep.
CI/CD specific for machine learning use cases is basically everything that you have with a normal CI/CD plus continuous retraining and continuous monitoring. And so for traditional, software, you're not really doing continuous monitoring. And so when you're monitoring machine learning model, it looks a little bit more like infrastructure monitoring than it does look like anything else. But there are specific monitoring tools that you use, and there's specific ways that we periodically retrain these models. And so right now, the majority of clients that I work with, you ask them about their retraining schedules, and they say, oh, well, I retrain once a week based upon this set of data, and they're all arbitrary choices. It's so first off, great, like you have a retraining methodology, and that's fantastic, but we don't normally have statistically rigorous retraining methodologies. And then for continuous monitoring, normally the answer I get is, maybe we take a look at how my evaluation metric is performing over time. But monitoring is a lot more complex than just monitoring your evaluation metric over time. So all of that to say is, in terms of the frontiers of this space for, let's say, 80%, 90% of companies, it does have a lot to do with the CI/CD specific issues, especially the continuous retraining, the continuous monitoring. Basically, stopping this practice of lobbing a pickle file, over the cubicle wall at your data engineer and say, hey, go take care of this. Because one of the most informative experiences I've had in ML ops came from a course that I was teaching at a major bank maybe 4 or 5 years ago. And the class was primarily data scientists, and we were walking through how to do some basic distributed machine learning. And so the class overall went really well. There were 2 very talented data engineers who were in the class. So they knew nothing about Python, nothing about data science. And we wrap up, this 3 or 4 day class. And one of the data engineers came up to me and, she was a little bit embarrassed about the question that she was going to ask, which is why she didn't ask it in front of the whole class. But she was like, what's a pickle file? And so we moved through this entire class. And so she was an incredibly talented data engineer. She was responsible for, the deployment of these models. And she was so immersed in the Java ecosystem that she had no idea what a pickle file is. And so for anybody who doesn't know what a pickle file is, it's a way of serializing Python objects. And a lot of data scientists want to train a model, serialize it as a pickle file, and then say their job is done. And so for me, that became so just the epitome of this distinction between these 2 different skill sets of how do you train a model and then how do you actually gain some sort of business value from it. And so I always think to myself periodically, if I'm working with people from these different personas, is what's a pickle file, right? How can we best bridge these 2 skill sets in order to get the best solution for figuring out a data science problem and then joining it with the rest of a more complex, application infrastructure.
Definitely. And in the tooling aspect, I've had questions like that as well. I mean, my experience interacting with our customers, our shared customers, is a little bit different than on the pure consulting side. We do a lot more of that conversation, like kind of what you were just talking about with the questions that people don't want to ask in a group. And sometimes they are questions that you'd be like, okay, I kind of get why you'd be concerned about asking this, because everybody else probably knows this esoteric term really well. And then you're the odd one out, but there's stuff that that everybody else would be like, what the heck is that? And I see that as something happening, particularly with ML ops with respect to CI/CD and passive retraining and active retraining and monitoring. It's too complex right now.
Mm-hmm.
You build an active retraining system for an online REST API served model. The list of things that you need to build, I guarantee you implementation of that is going to be 10 times longer than it took to build the model. Mm-hmm. and do the feature engineering work and do the research. It is very complex when you're talking about an active retraining and monitoring system that's processing 10,000 REST API requests a second. That's ML at scale online. And I think it's too complex right now to build those things. And I think it's going to be exciting seeing how certain companies enable customers to solve that problem in a more simplistic way in the future.
100%. Yeah, it's like we work in arguably the most exciting field, and where it's going to be in 5 years or 10 years is still mind-bogglingly exciting. I started this field quite a while ago and don't want to go anywhere else.
Yep, same.
Yeah, we're still way early on this stuff, and we're already doing extraordinary things with it. So,
Right.
All right. Well, I'm going to push us into picks because I've got another thing scheduled in 15 minutes. But before we do that, Connor, if people want to connect with you, how do they do that?
So a couple of different options. One is a website where I have esoteric musings on neuroscience, artificial intelligence, and philosophy. So if you're that kind of nerd, you can find me at just connorbmurphy.com. That's Connor with one N. And then also LinkedIn is a good place to connect with me as well. And that's just linkedin.com/in/Connor B. Murphy. Again, Connor with one N.
Awesome. All right. Well, let's go ahead and do some picks. Hey, folks, it's Charles Max Wood, and I just wanted to jump on real quick and let you know that I am putting together a podcasting course. I get asked all the time. I've been coaching people for the last 6 months. How do you start a podcast? How do you put it together? What do I need in order to get it going, et cetera, et cetera, et cetera. I've put together the curriculum, And I did it through coaching a whole bunch of people. And now I want to share it with you. You can go check out the course. It's actually going to be a masterclass. It's going to be a 4-week masterclass where I actually walk you through the entire process of launching a terrific sounding podcast and putting together content that people want to listen to. And you can find it at podcastbootcamp.io. Ben, do you want to start us off with picks?
Oh, man, I've been going down the rabbit hole with this new YouTube channel that I just discovered. I don't know why I didn't know about this guy, but Arjon Codes. He's an ex-CS professor. So I've been doing a lot more stuff in like pure Python, not specifically just data science Python. So the way that he goes through his code roasts in particular, I find it rather amusing that he calls it a code roast. I would call it more like an old school code review, where he's going through and looking at, problematic code and rewriting it live on his actual channel. So anybody who's just interested in seeing some different perspectives from from an expert in Python in particular, check out that guy's channel. There'll be a link in the description of the video. It's good stuff.
Awesome. Francois, what are your picks?
I'm definitely getting to the point where I'm realizing I'm not running across a life-changing technology or book every week. So I hope I didn't pick that one in the past. But yeah, it's Favreau. It's kind of a Kanban or whatever board. There's a million of these out there, like Trello to do project management or more task management type things. And it's a really flexible one. It's more flexible as far as you can have the same cards referenced by different boards. It's a bit more modular and pretty flexible. So there's a free trial. So like I said, I know there's a ton of them, but that one I like using. So there it is.
Nice. I'm going to throw out a few picks. I'm not going technical this week. One of them is Podcast Bootcamp, which is the 4-week course to get your podcast launched. I'm teaching it, and I am excited about it. You can go sign up at podcastbootcamp.io. And effectively, we're just walking you through kind of all the technical setup, which you kind of expect. But we're also walking through sort of knowing who you want to reach, knowing how to formulate your first 4 or 5 episodes so that you kind of get people to the point where they're understanding, hey, this is who I want to help and this is how, or this is the outcome I want from the show. Or if you're just straight up entertainment, right? Just making sure that people understand that too. And then setting it up in such a way to where you can kind of parlay that into selling courses or getting consulting clients or, whatever it is that you want to do. For some people, they just want to be well known. And this will set that up too, right? Because we kind of help you figure out how to set things up so you can interact with and be a part of the story for your audience members, which kind of is funny. I actually was out on a date with my wife on Wednesday, and we were at Cafe Rio, and I turned around to say something to my wife, and I was wearing an Adventures in Angular shirt, which is our Angular podcast. And the guy looks at me and goes, "Adventures in Angular?" He's like, "Are you on that show?" And I'm like, "Yeah." And then he looks at me. He's like, "Are you Charles Max Wood?" And I was like, "Yeah." And anyway, it was just, I get that at conferences when I go to conferences. That's not an uncommon thing. But you kind of concentrate the number of people that are likely to, if they listen to podcasts, be listeners of one of the shows on Top End Devs. But yeah, not usually when I'm just out and about town. I'll wear a JavaScript Jabber shirt and nobody stops me. So, and I wear it on the airplane, and the flight attendant will look at me and say, "Is that a coffee place?" Anyway,
it is now.
It is now. That's right. But yeah, I listen to books all the time, and I've been listening a whole bunch more since I've started running and biking to prepare for this triathlon. I haven't tried listening in the pool, and to be perfectly honest, I don't know what my swim coach would say if I tried. If I got headphones that would work in the pool. So anyway, but yeah, I'm spending several hours just out on the trail behind my house. And so I've got a couple of picks related to just things that I've been reading. I finished like 3 books over the last week. I think I picked Masters of Doom last time. So go check it out. It's great. But I've already kind of given you the synopsis on that one. The one I picked up after that was called How to Get Shit Done. I usually don't swear on the shows, but that's the name of the book. It's by Sean Whalen. And it's really, really good. It's like an hour and a half listen. It's really short, but he just kind of goes, "Hey, look, this is where I was, and this is how I figured my crap out. These are the 4 areas of life I focus on, and this is how I do it."
That's funny. I almost recommended a book called Getting Things Done. So
by David Allen, that's also good.
Yeah. I haven't put it too much into practice, which is why I didn't dare recommend it. But I guess it's a variation on your theme there.
Yeah, getting things done is awesome, except for that my wife stole my label maker, all of my paper clips, and my manila envelopes. So I'm not really doing getting things done, but I digress. It's a terrific book, and there are a lot of great ideas in that system. The other book that I've recently read is Tribe of Millionaires, and it's kind of about mastermind groups. And it's terrific. It's really terrific. I'm a part of 2 different mastermind groups. And honestly, some of the stuff that I picked up out of there is stuff that I really want to put out to these groups and be sharing at that level. So if you're looking to kind of level up your life, honestly, mastermind groups are really, really great. And because you get people that are invested in you, you get a level of accountability and feedback in your life and things like that. They've kept me from doing some pretty dumb stuff, right? That seemed smart at the time. And then it's like, no, you don't want to do that. And then after a day of me thinking about it, I'm going, yeah, I really didn't want to do that. But I totally would have pulled the trigger on it but at the same time, going through hard stuff, they're always there. I've got about 8 guys that I could just pick up the phone and call, and they'd answer my call and help me out. So, and they're all over the US. So just to give you an idea, but this kind of is going to help us kind of go deeper. There was another book and I can't remember what it was, so maybe I'll just save it for next week. But I've really been trying to just do self-improvement stuff, and these books have really helped me kind of think through, okay, what are you doing? What are you trying to do? What outcomes are you headed to? And things like that. And so anyway, those are my picks. Connor, do you have some picks for us?
I mean, riffing off of that, I have a book recommendation for you, my friend. So one of my favorite recent books is written actually by a buddy of mine called The Art of the Impossible. And so speaking of performance optimization, it's basically a primer on peak performance. So it walks through, the psychology of motivation. It walks through the neuroscience of peak performance, right? How to kind of leverage your attention to be fully immersed in what you're doing and optimize your productivity over time. And so name of the book again is Art of the Impossible by Stephen Kotler. Find that to be just a beautiful primer on all things peak performance. And then one of my other favorite recent books is a book called Scale by Geoffrey West. And it's one of the best treatments of the mathematics of every day. And so it goes deep into nonlinear relationships. So power law distributions, right? The Pareto distribution probably being the most well-known of those. It goes deep into that and deep into fractal mathematics as well. And the core premise of the book is, what are the various principles of scale that apply to living organisms, businesses, and cities? And you can see similar emergent properties across all 3 of those different systems. And so it's just a beautiful, beautiful treatment of those ideas. And it really teaches you the mathematics of everyday life in a way that's, practical and really stokes your sense of awe with the world. So I definitely recommend those 2 things. And then maybe just for a third to round things out, I've really been enjoying DJing recently. And for anybody who has an engineering disposition and doesn't know what the hell to do with music, just getting a basic DJ setup and playing around with all sorts of loops and filters and whatever, it's very, very mathematical. And the way I like to think about it is, if you play an instrument, you're kind of bound within a certain space of sound that you can produce. But if you're playing electronic music, you literally have the entirety of any sort of sound in the mathematics that goes along with that. And so it's just been such a nice decompression tool to, basically just be playing around with the mathematics of sound.
Nice. Very nice. Yeah, I just picked up The Art of the Impossible. That sounds really interesting.
Oh, you're going to love it. And please let me know what you think of it.
Yeah, I grabbed it on Audible. So yeah, we'll see. It'll probably be the one I pick up next, because I just barely finished Tribe of Millionaires. The one I read, the other one I forgot, was the Road Back to You. It's about the Enneagram, which is personality types. And it breaks down personality types. It's kind of a different approach. It was published by a Christian publishing company, so there's a little bit of Christian language in there. And then I'm Christian, so it's all interesting to me. But the thing that I really liked about it was that it breaks down each of these personalities, and it basically said it started at 8, and it goes 8, 9, and then 1 through 7. They're all numbered, and so I'm listening, and they get to 5, and 5's kind of the analytical person. information absorbing person. And I'm like, oh, that's me, except for this, this, and this. And then they did 7, and 7's the enthusiast, the thrill seeker. And that nailed it, right? I'm like, oh, I'm that, right? Mm-hmm. So, but yeah, it was really great because it kind of explains some behaviors that I have that I had never quite put my finger on. Oh yeah, I do that all the time, and then understanding why. And the same thing with several members of my family. And so I found it very helpful for that.
Awesome. I like it.
All right. Well, this was a ton of fun. Thank you for coming, Connor.
Absolutely. Thank you for having me.
All right. Well, I'm going to go ahead and wrap us up right here. And until next time, folks, Max out.
Thanks for listening.
Thanks, folks.
Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more.